welcome to Two Projects. In this video, we are going to explain the project, an intrusion detection method based on Transformer LSTM model. Introduction. The project focuses on addressing the escalating issue of web attacks and ensuring cyberspace security in the era of advancing internet technology. The primary goal is to enhance intrusion detection systems, that is IDS, by moving beyond traditional keyword and rule based methods. The project explores the integration of artificial intelligence, specifically deep learning techniques, to develop a more robust and adaptive approach to identifying network intrusion events. With the limitations of conventional detection methods in mind, there is a critical need for a more effective and versatile intrusion detection system. The rise in diverse attack methods necessitates an intelligent system capable of autonomously adapting to new attack patterns without relying on manual rule creation. This project is designed to benefit both individuals and organizations reliant on network services. Improved intrusion detection ensures a higher level of cybersecurity, safeguarding sensitive data and systems. The project's outcomes have the potential to contribute significantly to the broader field of network security. And by leveraging the power of deep learning, the proposed model combines transformer and LSTM architectures. Multiple attention mechanisms are employed to select and extract features, while the LSTM model facilitates understanding the sequential relationships within network traffic, enabling the accurate identification of intrusion events. Objective of the project. So, as I mentioned earlier, the primary objective focuses on creating intrusion detection systems that leverage advanced deep learning techniques. The emphasis is on designing systems with intricate capabilities to enhance the overall security of computer networks. And by introducing state of the art IDS, the project seeks to significantly improve network security. These IDS are designed to not only identify but also effectively mitigate various types of web attacks, providing a robust defense against cyber threats. And the project aims to create a dynamic system that adapts to evolving cyber threats. Achieving this involves implementing continuous knowledge based updates using machine learning. This approach ensures the system stays proactive, staying ahead of new attack patterns and enhancing its ability to counter emerging threats effectively. And real time monitoring features are integrated into the IDS to enable quick identification and response to potential security threats. This objective emphasizes the importance of timely actions in addressing and mitigating security risks as they occur. And the project investigates and develops various deep learning models, including DNN, LSTM, transformer, that is autoencoder, and hybrid models like transformer with LSTM. The goal is to identify the most effective approach for intrusion detection. This involves thorough analysis and experimentation to determine which model or combination of models yields optimal results in identifying and responding to network intrusions. Requirements needed to execute this project are software requirements. Software needed is Anaconda, primary language used is Python, front-end framework used is Flask, back-end framework used is Jupyter Notebook, database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of flow of work. So the first step is importing required packages. So this step involves importing essential libraries such as Pandas, NumPy, sklearn, TensorFlow, and Keras. These libraries provide tools and functions for data manipulation, data pre-processing, machine learning, and deep learning. The second step is exploring the dataset. So the dataset used for this project is the KDD cup. Exploring the dataset involves understanding its structure, size, and features to gain insights into the data that will be used for training and testing. The third step is data processing. So in the data pre-processing phase, the KDD cup dataset is structured using pandas and transformed into a Keras compatible format. Unnecessary columns are dropped and binary classes are converted for streamlined analysis, paving the way for advanced machine learning and deep learning exploration. The next step is visualization using Seaborn and Matplotlib. So here we employ Seaborn and Matplotlib to visualize patterns, distributions, and relationships within the dataset. Visualization aids in understanding the data's characteristics. The next step is label encoding using label encoder. In this step, we use label encoder to convert categorical labels into numerical format, making them suitable for training machine learning and deep learning models. The next step is feature selection. So here we apply the select percentile method with mutual information classification to identify and retain the most informative features, optimizing the model's performance. The next step is train and test split. In this step, we will split the dataset into training and testing sets to assess the model's performance on unseen data. This step is crucial for evaluating how well the model generalizes to new instances. The next step is training and building the model. Here, diverse deep learning architectures are employed. This includes training a deep neural network, an LSTM, a transformer based autoencoder, and an ensemble of transformer with LSTM. And in the next step, as an extension, we apply convolutional neural network. Additionally, we will create a hybrid model by combining predictions from multiple individual models to improve overall accuracy and robustness. And we have also built a Flask web framework as an extension to the project. So we utilize the Flask framework with SQLite for creating a web application, and we implement user authentication functionalities including sign up and sign in processes. So after signing in, users provide feature values through the front end. Later, the user provided input is pre-processed to align it with the format required for model predictions. This ensures compatibility between user input and the trained models. And we use the pre-trained models to predict outcomes based on the pre-processed user input. And then, application showcases the model predictions and outcomes through the front end, providing users with meaningful and actionable insights derived from the trained intrusion detection models. Now we'll understand about the algorithms used. So the first algorithm built is DNN, that is deep neural network. So a DNN is a neural network architecture with multiple hidden layers. In this project, DNNs are employed to learn intricate patterns within the network data. Leveraging TensorFlow and Keras, the DNN is trained to recognize and understand complex relationships, contributing to the project's overall capability for comprehensive pattern recognition. The second algorithm built is LSTM, that is long short term memory. So, LSTM is a specialized recurrent neural network designed for sequential data. Implemented to address the vanishing gradient problem, LSTM excels at capturing long term dependencies. In this project, LSTM models are applied to analyze sequence based network traffic data, allowing for effective detection of intrusion patterns that unfold over time. The next algorithm built is transformer, that is autoencoder. So transformers initially designed for natural language processing are adapted in this project as an autoencoder. The transformer focuses on feature extraction by learning condensed representations of input data. This aids in enhancing the model's ability to discern relevant features for intrusion detection, contributing to a more robust and efficient system. And the next algorithm built is transformer combined with LSTM. So, this hybrid model combines the strengths of the transformer and LSTM architectures. This approach harnesses the feature extraction capabilities of the transformer and the sequential analysis proficiency of LSTM. Used for enhanced performance, the combination of transformer LSTM excels in capturing intricate features and temporal dependencies within network traffic, offering a comprehensive approach to intrusion detection. Now we'll see the comparison graphs. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions showing the percentage of correctly classified instances. And this is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. So F1 combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is KDD Cup dataset folder in which I have KDD Cup intrusion dataset with class labels on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And this is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. So now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password and click on login button. So it has redirected us to the intrusion detection page. So here we have to fill in these parameters and click on predict button to get the predictions. First we'll understand these parameters. So the first one is protocol type. It identifies the communication protocol, example TCP, UDP, etc. used in network traffic. The next one is service. It specifies the network service or application associated with the connection, example HTTP, FTP, etc. The next one is source bytes, SRC. It quantifies the volume of data sent from the source host. And destination bytes, DST, measures the amount of data received by the destination host. Logged in is the binary indicator of user login status, that is yes or no. Count represents the number of connections to the same destination host. Service count, that is SRV count, represents the number of connections to the same service. SRV different host rate is the rate of different hosts connecting to the same service. Different host count is the number of unique hosts connected to the same service or destination. DST host SRV count is the count of connections to the same service from the destination host. DST host same SRV rate is the rate at which the destination host connects to the same service. DST host different SRV rate is the rate at which the destination host connects to the different services. DST host same SRC port rate is the rate at which the destination host connects using the same source port. DST host SRV different host rate is the rate at which the destination host connects to different hosts using the same service. Now we'll fill in these parameters. So protocol type would be 1, service would be 45, SRC bytes is minus 0.0, DST bytes would be minus 0.02, logged in is minus 0.4, count is minus 1.5, SRV count would be minus 1.18, SRV different host rate would be minus 0.20, different host count would be minus 0.84, DST host SRV count would be minus 1.7, DST host same SRV rate would be minus 1.8, DST host different SRV rate would be 0.08, DST host same SRC port rate would be minus 1.16, and DST host SRV different host rate would be minus 0.15. Now click on predict button. So here we can see the outcome, that is there is an attack detected and attack type is DDoS. So we'll try again, click on home link. We'll try giving another set of parameters. So this time protocol type would be 1, service would be 56, SRC bytes is minus 0.0, DST bytes would be minus 0.01, logged in is minus 0.41, count would be minus 1.55, SRV count is minus 1.18, SRV different host rate would be minus 0.20, different host count would be minus 3.5, DST host SRV count would be minus 1.76, DST host same SRV rate would be 0.59, DST host different SRV rate would be minus 0.28, DST host same SRC port rate is 0.82, and DST host SRV different host rate is 23.5. Now click on predict button. So here we can see the detection, that is there is an attack detected and attack type is probe. Click on home link. We'll try again. So I have entered another set of parameters. Now click on predict button. So here we can see the result, that is there is a no attack detected and it is normal. So it is benign. Click on home link. We'll give another set of parameters again. So I have entered the values. Now click on predict button. So here we can see the outcome, that is there is a no attack detected and it is normal. So similarly, we can give any set of parameters and can get the detections. Now click on sign out link. So the conclusion here is the project represents a significant stride in advancing intrusion detection systems, integrating sophisticated deep learning models for enhanced security measures. Through meticulous data processing using pandas and keras, the KDD Cup dataset is structured and transformed, laying a solid foundation for subsequent analysis. The exploration of diverse deep learning models, including DNN, LSTM, transformer, and hybrid architectures, demonstrates a thorough investigation to identify the most effective approach for intrusion detection. And the implementation of real time monitoring features and the development of adaptive systems that continuously update their knowledge base showcase the project's commitment to proactive threat identification and response. And the integration of a Flask framework with SQLite ensures a user friendly interface, allowing for user testing and authentication. The extension of the project to include CNN and a hybrid model reflects a commitment to pushing the boundaries of predictive accuracy in intrusion detection.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.